Okay, we're told that sine of some angle theta in a triangle is 5/7. So just draw a triangle. Theta is acute according to the start of the problem, so that means theta is not the right angle. So put theta wherever you want in your triangle. And sine is always the opposite divided by the hypotenuse. So for this triangle, the opposite can be 5, and the hypotenuse, sorry, opposite of theta, right? So that's why I put 5 over here. The hypotenuse is the one across from the right angle, so the hypotenuse is 7. So we can use the Pythagorean theorem to find this missing side, right? A squared plus that unknown side, we'll call it b. A squared plus b squared equals c squared. Doesn't matter which one's a and b, by the way. So subtract 25 from both sides. So b squared equals 24. So b is going to be the square root of 24. But we're in pre-calc, so we should know how to simplify that. If you can factor out a 4 or a 9 or a 16 or anything like that from your radical, do it, because that's called simplifying the radical. Look, I can factor out a 4 from 24. Oh, 7, 4, what is that, 6? Yes. Okay. 6 times 4 makes 24. But the whole reason we take out a 4 or a 9 or a 16 or a 25 is because we know what those square roots are. They're not even, but they're integers, okay? So it is, this missing side is square root of 24, or in other words, 2 square roots of 16, as 2 square roots of 6. Okay. But if it's a test or something, we can use decimal approximations. That's fine too. Okay, so I've got the full triangle labeled, and I did that because my instructions are to find the remaining trig functions. So I need to know what cosine of theta is. Cosine is the adjacent side to theta divided by the hypotenuse. And so the adjacent side is the one that's not the hypotenuse, the one that's not the opposite. So here's theta. This is the hypotenuse, so this is the other side that's adjacent. So 2 square roots of 6 over the hypotenuse of 7. There's cosine. Okay, we've got 2 out of the 6 done. Tangent is the opposite divided by the adjacent. So the opposite is 5, and the adjacent is 2 square roots of 6. Now in math, we usually don't like to have a square root in the denominator. I'm not sure why. I guess I have to think about it, why we're so picky about that. So this is fine. You could convert this to a decimal approximation too, but you could also multiply the top and the bottom by square root of 6 to get, that's because that's 1, so you're not changing the fraction, right? Still represents the same quantity. But in the bottom we get 2 times 6 now, because square root of 6 times square root of 6 is 6. So simplifying a little bit more, this is probably what you'd see in a textbook. That's 5 square roots of 6 over 12. Okay, we got sine, we got cosine, we got tangent, and now the reciprocals should be easy because cosecant is the hypotenuse divided by the opposite. So cosecant would just be the reciprocal of sine. So just take sine and flip it. There's cosecant. Secant, it's just the reciprocal of cosine. So you'd flip cosine. There's secant. But remember, you don't want radicals in the denominator, so I'll do the same thing. I'll multiply the top and the bottom by square root of 6. And on bottom, that gives me 2 times 6, which is 12. And then cotangent, just the reciprocal of tangent. So we get 12 over 5 square roots of 6. But again, we like to rationalize the denominator. Multiply the top and the bottom by square root of 6. Oops, and on bottom, that's 5 times 6. That's going to be 30. So we can simplify. That's 2 square roots of 6 over 15.